All right, episode 3. I think today I'll just go with an oldie but a goodie, one that I've done before, but I think it's useful to have this in its own specific frame. So today, what I'll do is I'll run through the Kineton framework from Dave Snowden that identifies the distinction between 3 qualitatively different kinds of system and how we might go out responding to those different kinds of systems. Okay, so to begin, the first kind of system is complicated. A complicated system is defined by the fact that the phase space, which is a concept that refers to the total possible states that the system might occupy, the sort of total possibilities that might occur within the system. The total phase space of a complicated system is finite and bounded, which means that whether it's small, like say the relatively simple space of a tic-tac-toe game, which only has a handful of number of different kinds of ways the game can be played, or very large, like say the phase space of a Boeing 777, it is, broadly speaking, unchanging. And for related reasons, causation, the relationship between cause and effect in complicated systems, is largely clear and therefore predictable. So what happens when you're in a complicated system, say for example you're dealing with tic-tac-toe, is that the appropriate approach is to see how much of that phase space, how much of the potential states of the system you can in fact grasp with precision. If it's a simple system like tic-tac-toe, then you can grasp all of it, in which case the appropriate response is to simply identify with clarity exactly what the outcomes will be of each move and then execute what will ultimately be a perfect approach. If the complicated system is too large for that kind of approach, say for example, again, our Boeing 777, where it's sort of implausible for anyone to endeavor to grasp it in its totality, nonetheless, one can become an expert and develop a lot of skill in predicting how it will respond to different inputs and outputs. Because remember, at the end of the day, it's finite and bounded. And with a properly constructed crew of experts, we can in fact go about managing that system very effectively and efficiently. Whether we're talking about building one or maintaining one, or in this case, flying one. And that's more or less what our civilization is very good at doing. It's very good at partitioning, identifying complicated systems, and then beginning the construction of levels of sophistication in crews of experts and then managing. This brings us to a complex systems. So where a complicated system is defined by the fact that its phase space is finite and bounded, and that the relationship between cause and effect is clear and predictable. A complex space is kind of the opposite, which is to say that its phase space is evolving. The states that it can occupy are themselves changing. The kinds of state that it can occupy are changing. So its phase space is unbounded and, as a consequence, infinite. And for related reasons, the relationship between cause and effect in a complex system is unclear. It is difficult, and sometimes, in fact, close to impossible, to predict the way that the system will respond to a given input. This does not mean, however, that a complex system can't be dealt with effectively. It just requires a different approach. And so the appropriate approach to a complex system is to learn how to be responsive to its disposition. While you cannot predict, and while cause and effect are unclear, in complex systems you do have correlations. It has probabilities that can be identified with some level of confidence. It has a disposition. And while this disposition is going to drift, if you become skillful at having sensitivity to the subtle signals of the system and become skillful in exploring the state and the space and the drift of the complex system, then you can respond to it effectively, or more precisely, adaptively. And this is the right way to respond to a complex system. And for me, the canonical example here is surfing. When you're surfing, you're dealing with a highly complex system. The wind, the state of the water, the temperature of the water, the direction of the waves, the intensity of the waves, the feedback between all these different things on each other, the kind of board that you have, the weight of the board, your weight, the way that you're paddling, your distribution of weight on the board. I mean, these are so many different feedback loops that the relationship between cause and effect is very unclear, and things are changing constantly. And there's no two times. There's no way to surf the same wave twice. Nonetheless, with a appropriate amount of experience and practice, you can build the capacity to become a very skillful surfer and achieve something that would be properly termed beautiful. And then this brings us to chaos. If in complication, the relationship between cause and effect is clear and predictable, and in complexity, we have it is unclear, and yet we have dispositions. When we finally get to chaos, we find ourselves in a circumstance where even dispositions go away. That, in effect, in a chaotic system, we have no basis for making good choices. So it's actually easier to just jump to the example here. We can imagine that we're on one of those enormous waves that Laird Hamilton made famous, and without knowing or willy-nilly, we find ourselves swept under by the wave, deep underwater, twisted head over tail, bubbles everywhere, and it's effectively pitch black. So this is chaos. We have no idea which way is up. And if we were to endeavor to swim to what we may think is up, we're just as likely to be swimming down or towards the rocks as we are towards the surface. And even if we made it to the surface, we might find ourselves still in the middle of the white-watered foam. Chaos. We can't actually yet make a good choice. And so the way that one responds to chaos is to wait, to slow down, to conserve your capacity to respond if and when the system transitions back into complexity. Go limp, conserve your energy, and wait. And when you then notice that perhaps light is up and the bubbles are all kind of going in the same direction towards the light, you've transitioned back into a complex space, and you can begin to redeploy your skillfulness, in this case, to swim to the surface. And that's pretty much it. So we have complicated, complex, chaotic. We have finite, bounded, clear causation, predictable results, appropriately met by expertise and crews of experts that can manage complicated. We have dispositions. We have subtle signals. We have experimentation and exploration and the construction of adaptive capacity in complexity. And then we have waiting, being in a liminal space, listening, becoming very subtle at listening, and allowing a chaotic space to transform back into a complex space. And that's all. I hope that this particular concept proves useful.